Oh, right. So yeah, here I am. So let's do some LeetCode. Yep, let's see. I've done 625, 20.2%. So that's like out of every five questions, done one. It's pretty good. Um, yeah. So wait, is it being streamed? Yep, my mouse is moving. All right. Okay, so let's do some problems. I'm pretty sure I've done this one before. Oh no, it's easy. I don't do easy ones. I only do medium hards. Subarray product list. No, I know I've done this before for today's. Yeah, it's solved. Submissions. Yep. Like, okay, fine. Back to problems. Okay, let's look at some companies. Is there like actually let's do this random pick one and keep doing it until I get okay, this is a hard and I don't want to do a hard. And it doesn't have an editorial, like it's grayed out, so no, that's not good. Let's just do another pick one. Or company based maybe. Oh, this is SQL. No, I want to do like the classical stuff. Okay, fine, I'll just select one. Let's do Facebook, Amazon, oh, okay, Oracle. One of my friends works there. He kind of hates it, but oh well. Okay, so this one, it's a hard that I'm in the middle of mediums. I mean, I've done LRU cache, right? Like LRU cache, so I don't see the need to do that. Like, wait, this is hard and that's medium, but aren't anyways, whatever. I mean, probably some linked list hash map stuff like that one. Oh yeah, let's look for like more frequency ones. Okay, so this one. Shall I sort? I'll sort on frequency actually. Word pattern two. Wait, it's a pretty low number, so I should have done it. That's weird. Typically, like the lore ones I've mostly done, like the more exotic ones, like 2,500, 3,000. Yeah, like recently LeetCode crossed 3,000 questions. Shall let's do this one. Yep. Okay, there's no editorial, so that's kind of a bad thing. Maybe that's why I didn't do it. Since I'm paying for LeetCode Premium, I get to like have access to like the solutions, the so-called official ones. But I guess like yeah, there's no editorial, so I guess maybe that's why I didn't do it. Like if you see them, like there's no like the green check mark solved. Okay, so let's do this. 29.1. We're actually let me start the time. 2:45. Oh, let's be very fancy. Let's be like formal about it. Let me do as if it's an actual interview. 2:45 start. So what's the target? I think like typically you get like 45 minutes to do like one or two mediums. Okay, given a pattern and a string s, return true if s matches the pattern. Oh, I see this is a two. Maybe it's like a word pattern one, but whatever. A string s matches a pattern. So you're given a pattern and a string, and we want to see if the string matches pattern. So what does that mean? A string matches pattern if there is some bijective. Okay, so bijective means if and only if. Bijective mapping of single characters. A string matches a pattern if there is some bijective mapping of single characters to non-empty strings such that, okay, that's a pretty long sentence. String match pattern if bijective mapping of single characters to non-empty strings such that if each character in pattern is replaced by the string it maps to. It's a very long sentence. I'm just reading my mind. Single characters to empty strings. Single characters to non-empty strings such that. So then there's a map that maps single character to non-empty string. That if each character in pattern is replaced by the string it maps to. Pattern. Oh, okay. Yeah, I think I know what's going to happen. Then the resulting string is s. Okay, so pattern basically, like you swap it out by the, like that's the key of the map. And then the value, you just kind of do that. And the resulting is s. Bijective mapping means that no two characters maps to the same string. And no, it's like a vertical line test, one to one. And no character, it's like, what's the thing? Oh, onto and whatever. There's two things that mean by bijective, or like just like two things. Like it spans everything and like the vertical line test or something like that. Two characters map to the same string and no character. So basically, like the mapping is 1-to-1. Like the value and the key are the only like that line is unique. Like there's no like cross lines. It's just 1-to-1 and onto. Yeah, 1-to-1 and onto. That's bijection. Okay, so yeah, no code. Okay, yeah, examples. A, B, red, blue, red. Okay, yeah, this is a very good example. Actually, I could have just skipped the whole description, but I guess like this whole like key thing is non-empty, I guess. But anyways, yeah, bijection. Yeah, so then red, blue, A, B. Yep. Yeah, this is the mapping. A, red. Okay, yeah, that makes sense. Pattern. Oh, oops. I just saw this. But anyways, to be honest, when I see such a low like number 20, like I know it's probably going to be like something exponential, like DFS or something, or like yeah DP or something like exponential because like 20 is a very tiny number. Okay, so then AB, yeah, so that's like A can like this bijection, this mapping can give this true. Like if we take this AB and we substitute the A's and the B's with this kind of mapping, then we get red, blue, and then since we can form S, then we return true. Then A, and then ASD, lots of repetition. Yeah, that's true. ASD, ASD. Yeah, so ASD. And this one, AABB, false. So like, let's just say that A is like XYZ, and like, or like you need like two of the same thing. So like XYZ, C. Yeah, so this is just false. I mean, yeah, nothing conforms to this pattern. So I'm thinking like something like two pointers, like it's like how would we get like red, blue, right? We would try red, and then like yeah, backtracking, like or like we kind of like do some prefix, like RE, and let's just like let's first let like RE be A, and then we kind of that's like one thing, then we backtrack, and then RED, okay, red, sure, and then B like BL, but then UE that doesn't like these prefixes do not match it, so then they're all like okay, yeah. So then, pretty sure it's back. Yeah, backtracking is an exponential algorithm, but since we have 20, then it might work. I mean, how else would you do it? To be honest. So, to pattern, and us, 2 pointers, pattern and string. What time is it now? So 2:50. So it took me 5 minutes. Okay, so then how do we do this? So like some helper, and idea is test prefixes of s, and like for each prefix or for each prefix, what do you want to do? Like two cases, right? Two cases. Case one is if it's already in the pattern. So like let's say we have seen red, we've seen blue, like we have this mapping, then here if we're RE, then like or like wait no, not prefixes, but like sorry, wait, no. So like the idea is to test it, no, not prefixes. So like okay, so then so like so in the backtrack, so like what's the idea, right? Like we have like kind of like a backtrack, I'll call that BT of P1, P2, right? Or BT of kind of like DP-ish, IJ, and a map, right? And a map so far, and a map so far. BJ like would be like so I is the index for pattern, and then like or pattern index, and S index. So like how do we solve this, right? So like the idea is like let's say that it's like red blue. So like we look at the pattern index and get the car, right? So then in two cases, right? either it's in the map or it isn't. If it is, then what? So if we have red and then we have blue and then like now we're at A again, then since we kind of have A and we know that A is in the map, then we better see red. If we don't, then we can just kind of abort and backtrack. If it is, then actually I think I can just start writing the code. Private boolean helper. I'll call this backtrack. So then we need a int pattern index, int us index, and then these I can just copy from here, right? Or not like that. Really, it's not doing it. Like that. Okay, let me just like shrink this. Actually, I can just delete this whole tab entirely. Whatever. Okay. Return, I mean the map, right? Map, character string. Let's call this just map. Or like, I think sometimes you call it dictionary. Like there's like this thing called alien dictionary or like some other LeetCode questions have dictionary, but let's call this map. Return, oh, I spelled backtrack wrong. Back, T-R-A-C-K. Backtrack. Let's just do autocomplete. So backtrack of a 0, 0, pattern S, and let's make this a new hash map. Hash map. And we're done. Oh, no, we're done. We have to implement this, and then we'll be done. Wait, why is there red? Okay, wait, what's the problem? Okay, so now let's consider edge cases, right? If, so let's say that we're done with S, right? Like if S index has covered, if we've covered all of X, right? Like the edge case, right? If S, and let's look at the constraints here. Make sure that everything is at least 1. Okay, good. So like there's no like null cases, no empty string edge case nonsense. S.length. So if this equals that, then what, right? And there's 2 cases. Then if we like look at P. So if we have consumed all of S, then I guess we can just do like return pattern index equals pattern.length, right? Like if we've covered all of S, then we must have covered all of, like if we've covered all of S and we haven't covered all of P, like let's say that like our pattern was like kind of AB, AB, B, and we've kind of finished all of that, then like there's still something left here, but there's nothing left there. And G, like length, right? Okay. Actually, I think we can do the same thing there, right? Because like there's the other like dual case, right? Where if the pattern index is equal to P, or actually we can kind of consolidate them into the whole thing, right? Something like that. Ah. Or, and then like instead of S, we just replace it with P, right? Pattern.length. Pattern index, like this, right? So like the idea is that if we have covered all of 1, that is or I'll call this edge case. Edge case. If covered all of 1, then to be true, then true if and only if covered the other, consistent. Okay, so that's the edge case. So now that we're here, outside this if block, that means that like we have not, like both of them are unfinished. Then car or car C equals the pattern, right? Pattern dot car at, and then pattern index, right? Pattern index car a pattern. And okay, let me just like visualize this, or let's think how the backtracking works. I think the invariant typically is that the map should remain like in every invocation of backtrack. Once it all finishes, everything bubbles back up. The map should be untouched or like unchanged. So like in let's say AB, like let's just say that we mess up and we do RE and then like we fail everything, then we clear, the map gets empty. So let's say that we have red and then we have blue, and okay, let's just say that's like something different. Like let's say that we somehow mess up or whatever, or let's just say that somehow like um let's say instead of AB, this was like ABCB or something. Let's say this input was ABCB, and then we have like A and B. Let's say that we have them correct so far, and we kind of see RE as one thing. We have to put that in the map, and then we kind of go here, then we recurse, and then that fails because B is, we already know it's BLU. Oh wait, no. Okay, so then let's say that like A would be red, we're in one trajectory, and then B, let's just say we're looking at BLUE, and let's say that this C, again, this A is a C, then let's say we test this prefix RED, and then I know it's not a bijection, but like then this would work because the remaining blue consistent. Let's say it's like RE, then we have D blue, and like that's like what we're left with is this index, and the pattern would be B, but then we know B already exists, so then we have to kind of backtrack out of that thing for C. So then what that means is like we'd have to backtrack. So in RE, we put that in the map and we continue to kind of go out of it. So like since this thing had like that RE and could have some other stuff, and like we have to like restore the map, backtrack out of it. Like say, yep, I admit that this prefix was wrong. Let me kind of clear out the map. Okay, so that's the invariant. Just preserve the map. Stress standard BFS. Backtracking. Okay, yeah. So there's two cases, right? So then back to here. So it's like if map dot contains key of C, else. So those are two cases. Then if the map contains key C, I mean if it contains the pattern, that means that the string better start with it. So like if s dot starts with, so then if s does not start with this pattern, that means we did something wrong. We can just straight up return false, I think. Why is there an error here? Oh, sorry, no, it's not C. It's map.getC. I think that's correct. Okay, so then here, the mapping is inconsistent. We have a problem. The map doesn't work for the map we have a problem. Or just just return false. Mapping fail. So we can just return false. And then we have not really like, if you're in here, we haven't really touched maps, so like returning false is completely fine. But then here, so now we know that it starts with that. Then what? Then so like if it starts with it, then we simply like recursively call backtrack, right? We just advance everything. So pattern index plus 1, because like we've successfully covered, we can jump to the next one. And s index plus the length, right? The offset is just the length. Map dot get c dot length, I think. Pattern s map. Is that not correct? Let's just say that let's say that we're at like red blue and then we're seeing red again. So like we're at 0, 1, 2, 3, 4, 5, 6, 7. right? So then 8, 9, 10. Like our next invocation should be here, and like the offset's 1, 2, 3. So yeah, that's correct. We just add that there. Okay, so this is good. So like here, I'll just put a comment. Simply advance respective pointers. Here, we basically test all the prefixes. Prefixes from the current suffix. Prefix of suffix. That reminds me of like the KMP string finding needle and haystack string STR algorithm. Like where every time we're working like some suffix, like these pointers basically define suffixes. So then prefixes of the current suffix of us as candidate. So that's why it's exponential, because we're testing like that's why like it's 20 as candidate mappings. Okay, for C, where this C is this car right here, right? So now for int end car end index equals to a what? Like our start is basically like the S index, and the end index equals S index. End index is less than S dot length, and end index plus plus. We're testing all possible prefixes, including the whole thing itself of the suffix. So this looks good. And then, at the end, obviously, like what we do is we just return false or return true. Wait, yeah, no. At the end, if we've like tested everything, like explored, exhausted everything, and we haven't returned true, or wait, no. Yeah, if we haven't returned true and have exhaustively searched all possible alignments, all possible mappings, we just return false at the end. Okay, good. So now, like, all we have to do is this for loop and we're done. What time is it now? 3:05. So I have done. Okay, I think I'm commenting too much. I'll just implement this. Famous last words. Okay, so we're here. Okay, I wish my screen were bigger. Oh well, that's fine. So then, okay, so then, substring, string, test, string prefix equals s dot substring from the begin index. What's the substring? Begin index, end index. Is the index inclusive or exclusive? Java string substring. Substring string begin index extends to, yeah, end index -1. Okay, so it's like more like the whole like the length. Yes, the length is that. So like the whole like zero index, whatever, end index -1. So it's not like, yeah, okay, so that's a little misconception. I knew there was like a -1 here. That's like trips me up sometimes. So our begin index is simply the S index, is it not? Yeah, just S index. And then our so this thing would be end index -1, because like it's like, so like let's just say that we start with S index, right? So then 0. What? What? So what happens? What is smiles that substring of 1, 1? 1 comma 5, 5 minus 1 is 4. So it's just like kind of 1, 2, 3, 4, and then like that's 5, that's 4, that's 3, that's 2, and 1 would be the empty string. 1 would be the empty string. So if you want like mile, that's like kind of like 0, 1, 2, 3, 4. Then you do +1. Oh, you do +1. Okay, you do +1, not -1. You do +1. So this would be +1 because like you have to like do index +1, and you have to do the -1 here to get it to, yeah. So like this is like 1. We have to like overshoot by 1 because of exclusivity. So that's your prefix, right? Then like so then what? So that's your prefix, and then now one thing is that it's a bijective mapping. So if s dot values, if map dot values dot content, wait, what's the runtime for map dot values? Values set. Like, what's the runtime of that? Okay, I guess I'll just like add new hash set map values. What's the problem here? Yeah, about that. Set string map values. Okay, so then right here, right? So if the map values does not or already contains the prefix, right? Continue not bijective to different cars can't map to same value. Okay, so now it's like kind of new, right? So now we know the prefix is like, it's okay to test. So now we have to like actually test it and do the advancing, like do the key stuff, right? Okay, so then map dot put our car, which is C, right? The C right here, the patterns, that car. We have to kind of give it a new mapping of this prefix, and then like kind of like something like this. We have to also like kind of do map values. Kind of put that there, and also map. Sorry about that. Something like this, and then like map values dot add the prefix, because the value of the map, and backtrack what? Pattern +1. Okay, pattern +1 will always map backtrack. Okay, that's fine. And then what? S index plus prefix dot length. Prefix dot length. Pattern S map values that look correct. Or wait, no. Actually, yeah, we can short circuit if it's true, right? Or yeah, we can short circuit this. If that is true, return true. Something like that. Actually, that looks better. Technically map.getC.length is that, so that's kind of fine, but just to be more to the point, prefix, less indirect. Pattern S map values, and we have to backtrack. So like, since we haven't returned true, that means like this whole prefix fails. So we have to backtrack. Map.remove C and map values.remove prefix. Something like to the effect of this. And that's my pseudocode. And index. What's the problem here? Oh, IDX. Okay, so this is like the general kind of my approach. Let's try running it, see what happens. Oh, okay, correct, wrong. Case 3, true and false AABB. You know what? It's 3:13. I feel like I've already spent half an hour almost, so I might as well just use the debugger. Let me just delete these first two test cases since I already got them. I just feel like using the debugger right now, to be honest. Okay, so I got true. Oh wait, no, yeah, this looks wrong. This looks wrong. This edge case looks wrong to me. So if pattern index, so if we have covered, like if we have hit the end for either of them, then we have to make sure that the pattern index is that, and s index equals to s dot length. So basically, if we have covered all of one, then true if and only if covered all the others. So like reached ends in both. Let me just reset my test cases and then run. Okay, now this one is correct, but this one is false. True. So then, okay, what? ST. What? Okay, let me actually look at the prefix. Just kind of. Let me just kind of debug this. So I don't see what's wrong with this. Like from a first glance, my code looks understandable. So AAA, ASD, 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 right? So I want to test for ASD. That's our like kind of our thing. ASD, right? So that's I'm gonna put a breakpoint here and just kind of step over and keep playing until it. So our prefix right now, or maybe here. So our prefix is what? Our prefix is E. Wait, no, let me just stop this. It's the test case. Red, blue, right? Just run everything. So we failed the first one, right? Let's A, B, red, blue. So that's the issue. Alright, debug. A, B, red, blue. That's the problem. Wait, sorry, not that. AP, AP, red, blue, red, blue. Okay. So we step into this, backtrack. So the prefix is R. Okay, let's just like skip until we let's just skip until our prefix becomes E. Wait, what? Wait, what? Why is there, okay, so that's the issue. This S index is 1. Oh wait, no, but that's the other one. Okay, I see the problem. Okay, let me just stop this. Step into it. Backtrack. So our prefix is R, okay. Then map.remove C. A is to R. So now we've emptied that, cleared that. And now the prefix is R. So like R failed, RE. I mean, okay, we just do the same thing. I want to make it get red. Okay, so now is the moment of truth, right? Our prefix is red. So we put that, and now that we've put that, what we want to do is we're going to recurse. So we want the pattern index to be 1, from 0 to 1 S index to be 0, 1, 2, 3, to be blue. So we step into this one, right? So now we're here, and now for blue. So the prefix for red, I want to do the same thing for blue. Now our C is B. What I want to do is I want the prefix to be blue. So now the prefix is B, so we just kind of keep skipping over until we get it. Now breakpoints don't work because the breakpoints, like, we want them for this current level of our recursion. We don't want to step in because like the breakpoints, what's happening is the breakpoints are getting hit like in this nested one. We want to skip our nested. Okay, so I want this to be blue. Our prefix is BL. BLU, okay. Now our prefix is blue, finally. So now the map currently has the correct values, red and blue, like red, blue. And now we want to kind of go deeper into the next pattern index, which would be 0, 1, 2 for this A. And then what would this one be? 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Okay, let's go into that. And now here we are, right? This is going to be A, correct? And what's our, 2 and 7. 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. Now, shouldn't this return true? Like, just kind of like do that. This should be true, right? It contains, we have our A, which maps to red, right? So now what we do is we're gonna like kind of, since we know that we contain it, this one we'd skip to go B, and then map.get C is A, which is red dot length. Okay, so let's go into that, right? So now where we're at 3, 0, we're at 0, 1, 2, 3, the very last one, and we're at 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, great. So now we're here, right? So this car is B. Okay, correct. But what? Oh, I see the problem. So right here is the problem. This should not be false. This is not S, right? Like this S, we want the suffix of S, right? Yeah, so here's the issue. Just this one line 13, it's like this is like this line right here is where my problem is. Cause like this is not like what we want to do is we want like what we basically want, right? Is instead of S, we want the suffix of S starting at a S index. That's the issue, right? So S dot substring dot substring of S index like that. Now let's run it. Okay, these all look correct. And then should I just submit it? Yeah, let me just submit it. I'm running out of time. And I beat 100% of the users with Java. Well, look at the histogram. Basically, everyone lands here. So okay, I mean that's a successful thing. So now let me just yeah, let me just clear everything. So in the future, I want to do submissions or all submissions. So now I have done my first submission. So if I go to description, it says solved. And then I had 625. It should be 626 now. Yep, 626. So I have done one just now. Okay, so it's 324. What time did I start? 45, right? I started at 2:45 and I finished at 3:25. So 45 is 15. So 15:25. It took me 40 minutes, but that was okay. It's under 45, but that's pretty slow. But I did waste time kind of talking about it. But overall, I'd say it's a pretty easy thing. Okay, so I mean, respectable. Now, yes, technically this is a bit wasteful because like I think like I'm getting this. I feel like I might have been a bit more efficient, like kind of like the me substring s dots like strings are immutable in Java, so like we're actually like creating a new string. Like this thing is creating a new one. We could have actually just like we could have like kind of like taken like this value here and then like kind of like used pointers and like tested like the characters. Like we could have done a character to character like test. Like if the map dot can if this map.getC has like length 4, we could have just like iterated from like s of substring s index plus 1, s index plus 2, s index plus 3, and like tested like that. And like kind of, we could have like been, I'm sure there's ways to be more efficient, but like I'd say it's fairly clean. So I think that this is a good job. Let's do another problem. Pick one, random. Oh no, I was doing company, right? I was doing Oracle. Let's do some more. Oh, yeah, Oracle, frequency. Yep. So now, wait, was it? Wait, no, wait, what? That is Google. It's not Oracle. I just want to see a check mark. Okay, so this is done. This is done. Pair of songs, total duration is divisible by 60. Now, this name is so long that I kind of feel it's a bit contrived. I don't know. Actually, I have to use the restroom, so maybe I'll just take a quick break. Well, actually, yeah, I can just select a higher. Yeah, let's do 2 years just to get more. And frequency. Oh, it's already sorted. Okay, I'm just gonna take a quick break and then head back. Right. Alright, sorry about that. I'm back now. Should I do? I mean, I could do a hard question too, because the first one seemed really kind of straightforward. But no, I feel like it took me 40 minutes, so I might as well do another medium. Shit, what was the percent rate on that again? 47.5. Okay, so like it's below 50, so it's somewhat challenging for most people. But surprising, but oh well. Whatever, I shouldn't show off. Okay, let's do this one. Okay, I don't like things that are too long, just and it's hard to, but yeah. Count number of good subsequences. It's unlocked. 54.5, fairly high frequency. I'll keep this in my short list. Actually, let's just do this. Yep, no submissions. And there's no editorial, so that's a bit concerning. A subsequence of a string is good if it is not empty and the frequent. Yeah, let me start the timer. Oops, just default that. The time is 3:30. That's a nice round time. Okay. A subsequence of a string is good if it's not empty and if the frequency of each one of its characters is the same. So unique, or wait, no, same. Given a string S, return the number of good subsequences of S. Since the answer may be too large, return it mod this thing. First thing you do when you see these types of things, you just like kind of like do this. Or like int mod or long mod equals 10 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 7. Like that. That's like the first thing you do. So given a string, the returner of good subsequences of S, our answer may be too large. Subsequence is a string that can be derived from action by deleting some or no characters without changing the order of the remaining characters. So like if a string has size n, there's 2 to the n subsequences, because for each thing, either it's there or it's not there. Each character from 1 to n, I from 1 to n, the ith character could be there or not. It's a factor of 2, therefore it's 2 to the n. Yeah, see, total so it's 2 to the 4. There's 16, and then there's 5 that are not good. A, B, 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 B. Wait, what? Subsequence is good if it's not empty and the frequency each one of its characters is the same. So this is not good because A is 2 and B is only 1. And this one is not good because A is 1 and B count as 2. And then same exact reason there. Hence the good number is that Leet is 12. Again, 2 to the 4. And you have if it is not empty, okay. Okay. I mean, do we not just like, is this not like backtracking or exhaustively searching everything? There's a hint, but let's not click that. A, B, C, D, 15. So everything is unique, therefore like, it's just everything except the empty one. I don't know, for me, for whatever reason, my intuition tells me that the empty one should be counted. But anyways. Okay, so length is like 10 to the 4, so that's actually kind of long. It's not like 20, so maybe not exhaustive. What's the acceptance rate again? 54.5. Yeah, this one seems hard to me. Hmm. So one thing that kind of I want to do is DP, dynamic programming of I, right? Like something like DP if I, and like return DP of 0, like kind of like that. So like, let's just say that we consider like the first one, 0 as A, right? Let's say we have the answer here. Then like DP of I being the answer for S, I, and like this substring inclusive, obviously. So if you consider this A, right, then one thing we can do is like return off these. So like equals, so DP of I equals what? Equals DP of I plus 1 plus what, right? It's like one thing is like, so DP of I plus 1, uh, if we simply ignore the ith car in all of the subsequences, the subseqs. So now the hard part is if we include the ith car, or how to include the ith car. Like, well, what do we do? So if we take A, then what? So again, I'm solving for dp0, right? So one thing is like, let's say we recursively have dp of I plus 1 as whatever this is. So like, what's this? You have like A, you have this B, you have that B, you have AB, you have this A, that B, like you have all sorts of different things. But like, it's that. Mm. So you have like kind of like x, x, and you want to solve like dp of here, right? And that's the last one or the next one. I feel like you like skip to the next occurrence of it and do that. So if you include this one, then that's like the same as like kind of skipping. If you include that one, hmm. Okay, let's just do like A, B, C, A, B, C, A, B, C. Then we start off at 0, like this A, right? If we don't include it, then it's just like the answer is whatever that is. But then if we include first A, then like that kind of like puts a count of 1. Wait, no, maybe like the count itself, right? Maybe like look at final good sub seek. Yeah, I had a breakthrough, I think. So look at final good street. Like each one has a K. Has a K. Like here, like has K. Has each good sub seek has a fixed count K for all. So like we could exhaustively consider all K from 1 to N, right? Like that. Like for this one, for AABB, like if K is 1, then you could have like this A and B, like this A itself. So it's like if K is 2, then you'd have only EE. So like we could just exhaustively do all the Ks and then kind of sum it up from 1 to N. Okay, so one thing that jumps out to me is like build a map of counts for all cars and like sorted somehow, right? Or something like that. Like if you have like 1A and like, or like if you have like 3A's and like 2B's and like 1C, right? Like something like like AAA, like the order doesn't matter. Like BB and C, like the order doesn't matter because it's subsequence. It's not like a sub array, it's a subsequence. Then like K equals 1 would be like just like you'd have A, like B, like A, B, C, um, AB, AC, BC, and ABC. You could have like this A, that A, like AB, C. So like these are the actual like values, but there's like three of these because you could like choose this A or this A or this A, and you could choose like two of those B's, and you could choose like one of those C's, and then you could like for AB it's like any of these and then like any of those, something like that, and like K equals 2 would be like, well, C is disqualified because they only have one of it, so like it's only like these guys could only have like AA, BB, and like AA, BB, something like that. And then for K equals 3, well, this one we're pretty much only stuck with AAA because that's the only one. These ones don't work. Now, well, let's say that this one was 4. Then what? NK equals 4. Just be AAA. Like we'd get all of these plus that, plus that, plus that. So like map, character, integer, car counts equals new hash map, 4 equals 0, I is less than s dot length, I plus plus, car c equals s dot car at I, and then car counts dot put c default 0, car counts dot get or default of C or else 0, its existing count or 0 if it doesn't exist, plus 1, and then list integer counts equals, and again, like this list like is size 26, lowercase English letters from A to Z to Z is 26, is car counts dot dot values and collections dot sort counts, or okay fine, collection integer. Get values. Sort values. List of all values. New array list map.values. Okay, that's what I wanted. Okay. Collection.sort counts. And max count equals counts dot get counts dot size minus 1 max count, and then 4 int k equals 1. K is less than equal to max count k plus plus, and we return some global sum. Return sum. Or long sum equals 0. Return sum mod. Actually, no, just return sum and something like that. So now I have to kind of exhaustively kind of sum up all the k's. Right. Okay, so let's just say that k is 2, right? How do we do this? Int I equals 0 for while counts dot get I is less than k I plus plus, right? That filters out all the old ones. And since we're doing it sorted, then we never have to decrease I. Only increases. Filter out counts that are too low. These will never be considered. These will never be considered in all further iterations. So it's like a nice kind of idea. We just kind of skip it. So now what? Now our I is like would be if the K is 2, then now we've kind of skipped this one, and like we're at B and A, right? Or let's say that like this is 2, and that is like 4, and this is 5, and then like we're at like K equals, say, like 3. Then like we've skipped this one, and now we're at like 4 and 5. So then how do we compute the contribution for 3? Well, we have to like kind of choose, we have to do like 4 choose 3, right? Or like, how do we, permutation, combination, like, what I want to do is do let's just say that we have like A is like 4 choose 3, or yeah, 4, or choose, let's say 5, and 1, 2, choose 3 A's. Could have like this one, like the first one, this one, this one, or this one, this one, this one, or this one, this one, this one. The point is that like we have to kind of fill in like this one. You have to like kind of fill in 3 entries. 2, 3, 4, 5. They're like kind of like 5 possible entries for the first one. And then if we choose for the 5 possible, like it's like there's like kind of like a 5 times 4 times 3 idea. It's like we're gonna have like this one, 5 A's, like kind of like A1, A2, A3, A4, and A5. Have like A1, have like kind of like 1, 2, 3. Have like kind of like 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 3, 4, 1, 3, 5, 1, 4, 5. So ultimately, like we have something in the form of x, y, z, and there are 5 times 4 times 3 possibilities, like for the x, y, z, but then like have to remove duplicates, like 1, 2, 3, same, like the same subseq as 3, 2, 1, or 1, 3, 2, and so forth. Hence, divide by something, by 3 factorial. So if we have KAs and or we have n A's and choose K, then that's n times n minus 1 times dot dot dot, like K times divide by K factorial to remove the duplicates. Okay, so that I just basically derived how combination works. It's like some stuff I learned in like maybe middle school, but yeah, or freshman year of high school or middle school, something like that. But it's very old stuff. Permutations versus combinations. Okay, yeah, so that's it. I should just build a table of factorial, I think. But yeah, then int prod or long prod equals 1. So then we're choosing like 2 of that. Like at the end we have like kind of like sum plus equals prod, and sum equals sum mod mod, something like that. So now it's just like to build like for a given k, right? So then we'd have what? Let's say k equals 3, right? So like we're doing 4 and 5. And for int j equals I, j is less than the counts dot size, j plus plus, int count equals counts dot get j, and prod times equals the count choose k, basically. Like that's kind of what we want to do, count choose k. We need some sort of like table for factorials. Let's build a table. Factorial. What's the maximum count? No, I can't take a factorial of such a large number. That's ridiculous. Mhm. Wait, hang on. K equals 2. That filters out the C to just A and B. You have like two, like you have different ways of doing that, and then this one. Is there like something fancier or like can we somehow like express like K equals 4 as a function of K equals 3 and like K equals 3 as a function of K equals 2? Ugh, stupid combinatorics. Should I check the hints? I mean, it's 4:08. I started at 3:30, so it's been like 40 minutes, and I haven't really done much. Okay, so maybe this technique for like setting like all these Ks might be too hard for me. Not sure. No, but I feel like building a map of these counts and sorting them is a really good idea. Just feels right. k equals 1, like each entry in the set itself, you have to do combinatorics to like figure out how many of these. Because like this A could be like any one of these. So for all the k's, we have to like generate all the k. Like this seems very like very expansive. Well, no, the order is kind of respected in the subsequent, so maybe we can't do map of counts. Mm, No, I don't think the order matters. Let me guess, the hint is the order doesn't matter. Mm. What time is it? 4:13. It's almost been an hour and I'm still stuck on this surprisingly medium level question. Let me see companies. Oh, yeah, Oracle I was doing. Too simple. It's a nice name. Oh, there are 3 hints. Wow. Well, I'm not a noob. I'm not gonna look at the hints. Oh, I'm thirsty. So for a given k, like 2, these both, we can have like any combination. Like say we have C1, C2, Cn, where all the Ci counts are greater than or equal to k, and many ways to get some assortment ways to form concats freak of K. C1, C2, C3, dot, Cn, like K of those, C1, C2, C1, C3, and so forth. Like just all of them. So like either the CI is there or it isn't. If it is there, then like it's a factor of CI choose K, I think, right? CI choose K. Else just one, and then take the final product and subtract 1 to remove the case where choose none of the CI. So I think I have kind of a closed form answer, or like, I think I have a formula for computing everything, but I don't know. Don't know. 10 to the 4. I do not want to compute such a huge factorial. Yeah, there's no editorial for this one. Okay, let me click the hints. Use frequency array of characters of the string. Okay, that's exactly what I was thinking of, like a list of counts. And 2. Count the number of subsequences of S where each character occurs exactly m times. Where basically that's what I was doing, except for m, I have the thing k. That's my thing. Okay, so far these 2 hints are exactly what I was doing. It's been 1 hour, but yeah. Okay, should I click hint 3? Yeah, let's click it. For any n and k, you can calculate n choose k mod p and O log p using binary exponentiation. Binary exponentiation. I mean, you know what's funny? Like, I was literally looking at N6, right? Of like this eek70.org. Like, I think binary exponentiation, when we duplicate this, kind of go here, or like if I look at like maybe introduction, or no, this is a CS170, or wait, like not one, not one. Oh, this is some propositional logic stuff. No, CS170. Okay, where's the counting stuff? Like, it is boring. I need like an actual handout. Let me just close this whole thing. What is this? Yep, yeah. So right here, right? Um, like this same thing, like this whole like even or odd, like what? What? Where's exponent? Yeah, modular exponentiation. Right here, like this. Like this is basically the like this is like this is similar to like I mean whatever. See, that's the thing. Like I was even looking at like the CI for like this choose K, but like I didn't want to like I didn't want to build a lookup table for factorial, but I guess like the crucial thing, because I was gonna say that like n choose K, like computing that for n like up to 10 to the 4, I was gonna say I don't see how to do that. But like the key thing is the mod p. Like this is like the this mod p is a saving grace. Like the whole fact that we're in this ring or like this field or whatever you call that. I don't know the math term for it, but this modular, like this whole like set or whatever, like you're in a you're just working in mod m or like you're working in set representation. Actually, where was I? I mean, I was actually like reading this myself. I was reviewing encryption, by the way, earlier. Like I was about to like do the extended Euclid's algorithm to like figure out like how to actually get the multiplicative inverse for division. But anyways, I'm getting off topic. But yeah, so like I think that like overall like my logic like kind of doing it like the crucial insight like this whole DP stuff I realize is kind of a bad idea, but like the whole crucial concept is that each goes like this line right here, like exhaustively looking at all the K's, like kind of like this like hint right there, count the number of subsequences where each character is exactly m times, and basically like replace m with k and like kind of like from one to the end, like from that like so like hint one and two, like where we look at the frequency, like I did the same thing. I kind of got the frequencies, I sorted them, and like I got like these two I got, and this one like I'll have to like personally review like the I'll have to review the techniques in my own time, but I think that like overall my approach was decent, but uh I'll definitely like uh copy this and I will further look into this on my own time. So I think that was a good point to just accept that this question I couldn't possibly. In fact, I'm curious what the like dislike ratio is. I see 24 likes and let's see the dislike ratio. Revert to old version. Okay, there we go. See 24 likes and 63 dislikes, and there's no solution. So I guess like that should have been a bit of a red flag, and maybe I shouldn't have even bothered with this question. But like, I still think that it's good to like just kind of. It's always good to like contemplate these things. I guess. I mean, it might not be like the best use of time, but at least for me, there's like satisfaction in doing so, and it's kind of nice how like I believe my approach was like kind of generally like yeah, I think it was good. What are the topics? Yeah, combinatorics. Yep, exactly. Combinatorics. like combinations, n choose k or whatever. Like, but I will definitely have to look at this whole thing. I'll have to look at that because I am curious about that. But I'll do it on my own time. But yeah, I'm surprised this is a medium. Like, for me, this would have been hard at least. I mean, like, if like this length wasn't so high, I could just build a factorial table. But yeah. Anyways, I'm wasting time. Yeah, that's enough. Should I do one more or no? I feel like I've done enough. I mean, I've done one question today, pretty easy, and then this one I feel like this is 1.5 out of 2. All right, I think that's a good place to stop. See, I'll just stop right now. That's all.